I'm going to go through the answers to the 5.1 quick check. So for each of these equations, then we want to go back and say what is the kind of equation and also balance the equation. So this first one here, this is a double replacement reaction. And we can recognize that because we have ionic compound, ionic compound, ionic compound, ionic compound. So they're just changing partners, double replacement. Now to balance it, I think it would be good to find something kind of semi-complicated. And let's say we just pick out these silvers. So here's 2 silvers here. We have 1 silver here. So if we put a 2 in front of this one and a 1 here, that will balance our silvers. Now we can sort of just say, well, let's look at nitrates. And the nitrate, we can pretend that's one big element for a double replacement because it stays as nitrate and nitrate. So we have 2 nitrates here, and we have 1 here, so we'll put a 2. Now that gives us 2 potassiums. Here we have 2 potassiums, so that's balanced. The next equation, we'll say, okay, this is a O2, CO2, and H2O. Okay, so that's a combustion reaction. Now notice that is still, like 2 chemicals turning into 2 chemicals. Okay, and we have several of our categories that have that same pattern, but the clue here is that we have O2 on this side, CO2, and H2O. All 3 of those are the clue that this is combustion. Now to balance, we'll go back and say, okay, just take our most complicated chemical, looks like that. We'll pick maybe carbons. So here's 3 carbons here, here's 1 carbon here, so let's put a 1 here and a 3 here, and that will balance our carbons. Now staying with this first compound, let's do hydrogens. 8 hydrogens here, 2 hydrogens here. So if we have 8, if we make this a 4, that'll give us the same number of hydrogens, 8 on each side. Now for the oxygens, I have 3 times 2, that's 6. 4 times 1, that's 4. That's 10 oxygens. So this must be 5 O2s to make that balance. Okay, third one. Here is 1 chemical, 2 chemicals turning into 1 chemical. Okay, in our pattern, we have 2 things turning into 1. That is a synthesis. And to balance, I would balance the oxygens first. Here's 3 oxygens and here's 2 oxygens. So if we can get that to balance, everything else will fall into place. So if I have 2 and 3, if I use a 3 here and a 2 here, that's 6 oxygens on both sides and my oxygens are balanced. Now if I have 2 Fe2s, that means I have 4 Fe's. And that's balanced equation. Okay, the next one, here we have 1 thing, and it's breaking up into 2 things, so we know that that's a decomposition reaction. And to balance, we'll say, well, let's see here, oxygen, oxygen, and oxygen. We're going to stay away from oxygens first because those are everywhere. We need something that's only in 2 places, so here's hydrogen and hydrogen. So here's 2 hydrogens, 2 hydrogens, so if we put a 1 and a 1, that will balance our hydrogens. Now for our oxygens on the left, I have 1 times 2, 2 oxygens. On the right, here's 1, so this must be 1 oxygen, which I can write as 1/2 O2. So I can balance this equation as 1, 1, and 1/2. Now I can also balance this equation by doubling everything and call it 2, 2, and 1. And either of those 2 answers is excellent. Both of those are perfect answers. Now the next one, last one, as I have an element and I have a compound turning into an element and a compound. And notice again, just like combustion and just like double replacement, it's 2 things turning into 2 things. But the clue here is I have an element and a compound, and I have an element and a compound. Okay, that is a single replacement reaction. Okay, the copper is replacing the silver. Now, to balance this equation, I would pick something that looks a little bit complicated. I would take this one, and I'd say, well, let's say you have 2 nitrates, and here I have 1 nitrate. So if I put a 2 here and a 1 here, I have balanced my nitrates. This gives me 2 silvers, so I'll put a 2 in front of the silvers. And I have 1 copper, so I'll put 1 on the copper. And that's balanced. And that's the whole quick check.